Welcome! On this episode of Tomorrow's World Today, we visit the world of innovation to learn how innovations in compressed air and a math equation from the 1700s are being used in modern manufacturing. Our field reporter Greg brushes up on his ABCs, and we celebrate the first ever National Pneumatics Day. From Inventionland World Headquarters, here's our host, George Davison.
Throughout history, we've used the air we breathe to power things, like blowguns, which date back as early as 429 AD. You know, a blowgun is simply a long, narrow tube that you shoot something like a dart out of. They're surprisingly powerful, they're accurate, and they can shoot upwards of 100 yards. And you've probably seen bellows used to fan a flame. When the boards of the bellows are separated, air rushes into the chamber. When the boards are brought together, the valve closes and air will rush out through this nozzle. This is one of the very first uses of compressed air. Today, compressed air is used over and over in our everyday lives, like when the dentist uses it to clean our teeth, or when we're filling up our tires when the air's low. We're gonna head over to the wood shop now for a demonstration. Hi, Stu.
Hey, George.
Well, are you ready for the demo?
Absolutely. Take a look at this.
All right.
So this is the Bernoulli grip. Works off Bernoulli's principle. You can see here, we have a compressor in the other room.
Okay.
It's blowing high-speed air with these blue arrows here. And it creates a low-pressure field right in the middle with the yellow arrow.
Yes.
Which works like a vacuum. So the outside air pressure holds whatever material you want right up to the base of it. And it won't even touch it.
Wow, that's really interesting. Let me make sure I understand this. So in the other room, in this illustration, there's a compressor running that's filling a tank. And it's forcing high-speed air out of that head, right?
Yep.
When it does that, it's creating a vacuum right here in the middle. Is that right?
Exactly. And you won't even be touching your part. It creates almost like a little hovercraft in there.
That's nice. So no damage to the part if it's really a sensitive piece.
Exactly.
Very nice.
You know what? And this is one of those times where science feels like magic. You know, air's blowing out of this, but it creates that vacuum with the outside air pushing it right up in there. It's amazing.
It seems surreal, really.
Yeah. You want to take a look?
Of course, Stu.
All right.
See through it. Yep. It's not even touching, right?
And there it goes.
That's amazing, Stuart. Thank you for the demo.
Absolutely.
To learn more about how compressed air is helping to innovate the world of manufacturing, we're going to be visiting SMC, who invented an air cylinder actuator in the 1970s. An actuator is simply what's responsible for moving or controlling parts. They've got some great lessons and experiments in store for us that are going to help us to understand the science behind air compression. I've sent Greg to SMC headquarters in Indianapolis to get more information. Let's catch up with him on site.
You know you've made it when you've got your own road named after you. I'm here at SMC, where they're using their actuators and compressed air to help support the automation process in manufacturing. We're going to meet with John Halverson and Amanda Weiss. They're going to give us a little more information on the science behind some automation necessities. Hi, Amanda. Hi, John. Really great to meet you two today. I understand we're going to be doing experiments all day long. This is going to be so cool.
Yes, it's going to be very exciting, Greg. John and I are going to show you 3 different demonstrations to show you SMC's version of the ABCs.
The ABCs?
That's right. Let's go see.
So, Amanda, I'm going to need you to explain a little bit more about these ABCs.
Of course, Greg. Today we're going to be talking about air recycling, Bernoulli's gripper, and the compact wireless.
Let's start with air recycling. You're familiar with pneumatics, right?
I am. Anything with a pneumatic component uses compressed air as its energy source. So everything from nail guns to roller coasters, they all use compressed air.
Exactly. You've done your homework.
I try.
Very good. Let's go look at the first demo.
Sounds great.
So Greg, in addition to nail guns and roller coasters, pneumatics is commonly used in a variety of industries. SMC is a company that's helping those manufacturers reduce their carbon emissions through our technologies.
Well, that's great.
So the demo that I have here is a standard pneumatic actuator and our air-saving pneumatic actuator. When I extend and retract the cylinder, I'm putting air pressure on either side of the piston to move it back and forth.
Right, but that means you're wasting air in both directions.
That's correct. Every time I cycle this actuator, I'm actually releasing the used air back to the atmosphere. Versus in this air-saving model, I can extend the cylinder using compressed air, but when I retract the cylinder, I'm using the same air from this chamber.
So you're saving half the air.
Exactly. We're saving approximately half the air, which results in half the air compressor runtime and half the electricity and half the carbon emissions.
That's great. Amanda, what's next?
The Bernoulli gripper.
All right, let's see the bee.
So Greg, are you familiar with the Bernoulli grip?
I am.
The Bernoulli grip allows you to have the air pressure and the speed inversely related. So when the speed of the air increases, the pressure decreases, which allows us to pick up the objects.
Right, so that's basically the reasons why birds can fly and we can't. It's about the shape of their wings. When they flap, they generate a lot of pressure underneath and it gives them that lift. I can flap my arms all day long and I'm never going to take off.
Exactly. So right here is our Bernoulli gripper. It allows the air to move very quickly through the holes in the bottom of the gripper, which creates a suction in the middle. But what's really interesting is the fact that it doesn't actually have any contact because there's a thin layer of air above the object.
That is interesting. Let's see it in action.
The design is also a high lifting force, so you can pick up a little bit heavier objects too.
And it's not actually touching the product.
Exactly.
That's pretty fascinating.
So this is a little bit different than these ones here because these are suction cups that use a vacuum generator. So this is our ZK2, which saves about 90% of the air consumption because once it reaches a certain pressure, it just pulses the air so it maintains that pressure rather than continuously supplying the air.
Okay, so that's basically how birds stay up in the air once they're up there. They only flap their wings every once in a while and yet they stay airborne.
Exactly, because that sounds like a lot of work. The vacuum products will allow you to actually reduce some of your repetitive motion, so it's actually easier for us as well. The very first cup that we're going to look at is this FDA cup. It's blue because it's non-naturally occurring in nature, which makes it ideal for food applications. So it could be used for potato chips or cookies or picking up different things like that.
Just picking things up, moving it to a different area.
Exactly.
Let's see it work on our little bag of fake blueberries there.
Perfect.
Awesome. Very interesting. Now, as I look along here, these all seem to have a fairly similar shape, but this one is pretty interesting to me because it's pretty heavy. It's about a half a ball bearing. It's got a little bit of heft to it. I want to see if this will pick it up. No problem at all. Now, one thing I'm noticing is that these shapes are similar, and these two in particular look exactly the same. What's the difference between these two?
So if you notice, this is a thin film, whereas these are bellows, so that's why you can pick up this heavy round object.
Okay.
These two are a little bit different because they're a different material type. This is a nitrile rubber, which is really good for general industries, so you can pick up the glass there, cardboard, or even automotive hoods.
Okay, but this one would be better in maybe some heavier dutier applications, things like that?
Exactly right.
Okay.
So I know we had a lot of fun here, and I know we want to probably keep going, but John, what do we have next?
Yeah, let's get to the C, our compact wireless system. We've looked at our actuators and vacuum and how we can reduce air consumption. Now let's look at a way that manufacturers can increase their uptime and simplify machine design.
Sounds great. Let's take a look.
All right, let's go. So Greg, most manufacturers rely on 24/7 operation. And what we found is in their machine designs, one of the biggest problems they run into is communication cables and losing communication. That can be the weakest link in a machine.
And I imagine along with that, you have to worry about protecting that cable depending on the environment that it's in. You have to look at how flexible it needs to be, how far the information has to travel, how quickly that has to happen, and what happens if that cable fails.
Right, and there's all that labor to do the cable installation, to repair the cables, and think about it, all the landfill waste on the broken cables.
Man, that looks like the back of my entertainment center.
Yeah, so let's just do that, and we have a simplified way to deal with that. Here we have our EX600 wireless system that takes one communication cable from a controller to our base unit. We have this base unit communicating wirelessly to this remote unit, and we can have up to 127 remotes, including our new compact version. This compact remote can be used in a packaging machine where they want to have a really small profile and just keep their overall machine design small.
Now, I can't imagine, though, that you're just going to walk into a manufacturer's office, plop this stuff down on the desk, and walk away. You've got to have some way of training and educating them on how to use it.
Exactly. So although these are very complex products, if someone's willing to learn, we have a training facility just for them.
Great. I'd really love to see that.
All right, let's go meet Beth.
Okay.
Yes, there. Have me here. Hi, guys. So we've been talking about actuators. So let's think about what you know about actuators. What are your movements?
Linear.
Linear, very good. Give me a second movement of an actuator.
Gripper.
Gripper. Give me a third movement.
Rotating.
Rotating, all right. Let's talk about how do I pick the valve that goes with the actuator, because the actuator is going to be picked by my application. In this case, we've already picked our actuator. We've picked a double acting actuator. So let's start simple. Let's start with the most basic valve we've got, which is a 2-2. Air comes in, air comes out, and now I have to figure out how I want to move my valve. We're going to start with returning it. The easiest way to return it is a spring. So I put a spring in. Now there's a lot of different ways I can move a valve. I can move it manually, I can move it mechanically, I can move it with electro-pneumatics, which is what we're going to choose because that's what a lot of industry is going to pick. I'm going to send a signal. When I send my signal, I shift my valve, my air goes through, send my actuator out. When I stop sending my signal, my valve's going to shift back, and we would anticipate the actuator come back. Even if we had the method to send it back, there's no place for it to go. We can't send our air out. 2-2s don't work. So we're gonna add a port. I'm just changing the internal construction. I send my signal, my air is allowed to travel through, my actuator goes out. When I stop sending my signal, I have a path for my air to leave, which I didn't have with my 2-2, but I still don't have a spring in this, so I don't have a return method. We're gonna go to a 5-2. 5 ports, 2 positions. 1, 2, 3, 4, 5. 5 ports on both sides, my air comes in, and I'm gonna change how I have it plumbed. Air on both sides. Now if we look, my air's pushing it back. I have a path for my air to leave. When I send a signal, when I shift my valve, my air goes up, my actuator goes out, my air goes through. When I shift it back, my air comes back, my piston goes back, and my air is allowed to evacuate. So what we're going to do is we're going to go look at the production simulator and look at some applications and some examples of those different valve and actuator combinations. All right, so now we are at the FMS.
Well, what does FMS stand for?
Good question. FMS stands for Flexible Manufacturing System.
Okay.
And so what this is a mock-up of what you would see in industry. So it has a lot of different combinations of actuators. So we've talked about how we have linear actuators and how we have rotary actuators and we have grippers. And on this particular station, we've got all 3. And they all work together for one purpose.
Okay.
So in this case, what we're going to do is we're going to have this station install a bearing into the body. So now that it knows that it's here, we're going to have our linear actuator go out and push a bearing. Now our gripper and rotary are going to pick up our bearing, move it to a second station, where that station is going to take a linear actuator and measure how big our bearing is.
Okay.
And then we're going to have our last rotary and gripper combination, pick up our bearing, and install it in the body.
Okay, now this whole situation looks as though it's a simulation of an entire production line.
Yes, it does. It has all of the pieces and all of the sequencing that you'd see in industry. But to understand how it actually works, let's go look at a bench and look at some actuators and air up close.
Let's do it.
Let's go.
Yeah, just finish this up right here.
How you guys doing?
Oh, hi, Beth.
Nice.
Okay, so tell me what we're looking at here.
What we're looking at here is a close-up of what you would see on the bench. So now we're looking at two actuators that are working in sequence to have for a single idea.
Okay.
So before we were using sensors that said, hey, where's my actuator at? Now we're using these valves to say, where's our location? So those two talk about this one, and those two talk about that one.
Now,
But
how do they get their information for each other?
air, and actually the other valves.
Okay.
So this valve right here is controlling that information, and it's saying, hey, I got this information from this valve, we're gonna move that actuator. Same with that one. So it's all about information, it's all about air.
So this whole thing is just pure pneumatics.
Nothing but air. I think John and Amanda have a surprise for you.
Let's go check it out.
Let's do it.
Hey guys.
Hey,
Hey, so students are gone, so I'm done for the day, but I don't think you are. So it's been fun. I'll see you guys later.
All right, Beth,
Bye,
thanks a
Beth.
lot. So what is this surprise I'm hearing about?
Well, John's going to head over to Invention Land with you to help kick off the festivities for National Pneumatics Day on April 27th.
now we're trying to keep it a secret from George, so if you can keep it quiet, that'd be great.
I'll do my best. It's tough to keep anything from that guy, but we'll
Right.
see you back at Invention Land, all right?
Awesome, sounds
okay,
good.
I'm taking these wheels because this place is huge, and I need to wheel on out of here. So off
All
we
right.
go
Bye, Greg.
to Invention Land and beyond.
Bye, Greg.
See you, Greg.
What is all this? My office. What in the world?
Hey.
Hey.
George.
Oh, hey, John. How are you?
Good to see you. I couldn't help but notice that you found our surprise.
Is that what's under there? A surprise?
It is. So I'll go ahead and unveil it since you've obviously found it. I worked with your staff on this. We'd like to award the first ever Sustainability and Automation Award to Tomorrow's World Today for helping us to share our message with a wider audience.
Thank you very much, John. It's very kind of you and your operation. We're happy to do that.
Actually, today is also April 27th, right? Which is National Pneumatics Day, a day dedicated to sustainability and automation.
You know, John, I don't know how you pulled that off, but that's a good idea.
Great.
So tell me, what else has been going on over at SMC?
Yeah, well, thanks for sending Greg over. We had a chance to look at some demonstrations, and we taught him about the ABCs of pneumatics. A for our air recycling cylinder that consumes 47% less compressed air than a standard cylinder.
Wow.
B for our Bernoulli gripper. And C for our compact wireless system. Our compact wireless system eliminates wires between a base unit and multiple remote units, allowing for industrial communication between two points wirelessly. It eliminates cables and helps our customers with uptime so they don't have cable breakages.
No cable breakage, nothing going out to the landfill. That's great.
That's right, yeah. In addition to reducing operating cost and energy consumption, we can also just reduce materials altogether. We also had an opportunity to put Greg through some training. He actually sat in on one of our classes.
Oh.
We bring in students and as paid employees and train them on pneumatic technology and other industrial technology, so then they can go out and help our customers to implement this new technology and improve their sustainability.
Wow.
So what are you going to do with the award, George?
We're going to put that up in the main hall, and we'll be able to tell the story of pneumatics and technology and where it's going in the future.
All right, well, hey, I'm happy to have left this behind, and I'll see you later. Take care.
Thank you, John.
To learn more about the content in today's episode, visit us online at www.tomorrowsworldtoday.com.